In this video, we are going to be looking at Core M20, determine whether a function between two groups is an isomorphism. So the first thing that we have to do is we have to go through a definition. So let G and H be groups. An isomorphism is a bijective function, phi, that maps G to H such that for all xy in G, phi of xy is equal to phi of x, phi of y. If there is an isomorphism between the groups G to the group H, we say that G is isomorphic to H. Now in this line here, we don't necessarily know what that operation is because it can be any operation, but that operation must apply to both sides. So, some helpful tips and tricks. Be sure to know the group operations for both groups G and H. It's also sometimes helpful to know the identity elements and know how to find the inverses of each group. And of course, we need to check if the function is both onto and one-to-one, because that is what defines a bijective function. So we're going to go right into an example. We're going to consider function f that maps z plus onto z plus, defined by f of n is equal to negative n, for n in z, where z plus is a group. So again, our steps are to show the function is one-to-one and onto. So if we look at the first step, one-to-one, consider n and m in z and showing that f of n is equal to f of m. In this line here, I have set the two sides equal to each other. Here I have manipulated the right-hand side of the equation and applied my function to get negative m. And then I do the same thing with the left-hand side to get negative n. And we can say that negative n equals negative m. And by cancellation of those negative signs, we get that n is equal to m. This then confirms that our function f is indeed one-to-one. Now as we move on to the next step, checking to see if the function is onto. We are again going to consider n and m in z, and this time we are going to consider f of n plus m and see if that is indeed equal to f of n plus f of m. Our operation here is addition. So I'm going to start by manipulating the left-hand side here to make it look like the right-hand side. So I take my f of n plus m, and by applying our function f, I get negative n plus m. By distributing that negative to both elements inside the parentheses, we get negative n minus m. By pulling out a negative from both elements here, we get negative n plus negative m. When we apply our function, though, in reverse, we can see that this indeed does equal f of n plus f of m. Therefore, we can say that f is onto. Now that we have shown both of those, we can say that we have an isomorphism from z plus to z plus. Thanks for watching.